So if we look at sample problem number 1, the first thing that we need to do is we need to get the fourth root of x by itself. So we're going to subtract 5 from both sides, which is going to leave us a negative fourth root of x equals to negative 5. Now, it's very important that you understand that this negative in front is like a negative 1 being multiplied to the fourth root of x. So we're going to divide both sides by negative 1 here. This is going to give us the fourth root of x equals to a positive 5. Then at this point I have the fourth root of x isolated, so the radical part is by itself. So I'm going to raise the entire thing to the fourth power, and I'm going to do that on both sides. Now the root and the power will cancel each other out, and that leaves me x equals 5 to the fourth power. And if you don't know that yet, you can just simply 5 raised to the fourth power, which is going to give us 625. So that's sample problem 1, part A. Part B, however, gives us an expression with a rational exponent. And again, we need to isolate this first. So the first thing I'm going to do is divide both sides by 3, which is going to simply leave me x to the fourth third power equals to 81. Now, in order to offset this, we're going to want to basically take the reciprocal, because we know that the reciprocal of 4/3, when multiplied by it, is going to give us 12 over 12, which is equal to 1. That's the effect we're looking for. So I'm going to raise this to the 3/4 power. And again, you can do that to both sides, or you're going to need to. So the 4/3 and the 3/4 when multiplied together are going to give us that desired 1, or x to the first power. Now, with 81 to the 3/4 power, you have a couple choices here. You could rewrite this as a root and a power. Either way, you're probably going to have to put this directly into your calculator to get an answer. So if we look at this, I'm going to take this, I'm going to take 81, and I'm going to raise it this time to the 3/4 power. So I'm just going to do 3 divided by 4 in my calculator, and that's going to give me my final answer, 27. Okay, very good. So let's move down to the next example. And we're not doing anything new or different, but you can see here that this time my radical expression has a much bigger expression underneath it. And again, the first thing we need to do is we need to get that radical expression isolated before we can use the square to eliminate the radical expression. So you can see here that we get the radical expression isolated, and we could square both sides to eliminate that. And then it's just a good old-fashioned Algebra 1 problem from there. So use that as an example for sample problem number 2. So go ahead and pause the video and work sample problem number 2. Okay. So if we look at sample problem number 2, first thing we want to do is we want to isolate the radical term. So we're going to add 4 to both sides. That's going to give us 10. And now we have a square root, so that's an understood 2 there. So we want to square both sides, and the power and the root are going to cancel each other out, which is going to leave me 2x plus 8 on this side, and 10 squared is going to leave me 100. And now we just simply solve for x. So 2x is equal to 92, and then x is equal to 46. Okay, very good. Straightforward enough. So now let's take a look at example problem, I should actually say 3 or 4 here. Example problem number 4, we have 2 sets of radicals. And so before we can actually take the square both sides, this little negative in here really complicates things. If we were to move this, however, to the other side, then we could take the square of both sides and it would eliminate the radical for me. Now, pay very close attention here. on this right side, when we take the square of both sides, the square has to go to the 2 and it has to go to the radical. So if you remember your exponent properties, you've got to distribute that to everything in there that's being multiplied together. Now, keep in mind you don't do that on the left side because that expression is all underneath the radical together. So the 2 is just eliminating the square root and everything else from underneath is coming out. So a little different look at a similar problem. So for sample problem number 3, use that previous example and work this particular problem. Okay, so the first thing I'm going to do is I'm going to add 3 times the square root of 2x to both sides, which is going to leave me square root of 4x plus 28 equals to a positive 3 times the square root of 2x. Now I have a radical on both sides, a square root, so I can square everything on both sides, and of course that's an understood 2, so the root and the power cancel each other out, leaving me 4x plus 28. And again, in this particular case, the radical goes to both parts, so 3 squared is 9, and then of course the radical and the power eliminate each other, just simply leaving 2x. And now I can simply solve from here, so I'll need to multiply the 9 times the 2, and then get my x's on the same side, so I'm going to subtract 4x from both sides and then solve for x. So x equals to 2. Okay, so that ends our lecture on solving radical equations. You realize we can also do this with rational exponents, and all the skills that you've learned in previous lectures will come in handy here.